Okay. So you go to B3, type equals lookup, press Control A, and press OK. So you have a function argument box with 3 syntax arguments. You have the lookup value, you have the lookup vector, and you have the result vector. I did mention to you last time that in Excel, when you open a function argument box and you find syntax arguments that are in bold, it means that they are mandatory. Whereas those that are grayed out, they are not mandatory, but you need to know the consequences of leaving it or having it as part of your formula. So the lookup value is a unique identifier, and it is cell-based, meaning that you cannot pick a range for a lookup value, pick a particular cell. So in this case, our lookup value is in A3. So meaning that if I didn't want to type A3, I wanted to make it to hard code it within the function argument, I could still type B in here, but then I'll need to put inverted commas. But this is not our intention. We want to link it to a cell. So in this case, it will actually fall in A3. Then now we'll go to the lookup vector. The lookup vector, we can, because it's mandatory, we could still just pick this whole thing like this. Meaning that the result vector will be the last column within the lookup vector if you choose to do that. But in this case, we want to go stage by stage so that it is easier for you to understand the function. So this is what we are going to do. So say lookup vector, we'll pick these codes because it should actually rhyme. It should sync with the lookup value. The same principle that we looked at under VLOOKUP and HLOOKUP. So we'll pick the lookup vector. Then we'll say, what do we want? The result vector. The result vector is the column where you want to pick your results. A column or row, depending on what you're trying to pick. So in this case, we want to have the result. We want to have, I don't know what have I done. Oh, sorry. B3, I hope this is well aware. Looked kind of fun. So the lookup value is that. The lookup vector is this. The result vector, where we want to get those results, it is in there. So you do like this. Then you can press OK. So if you type A, and the advantage is that this particular function is not case sensitive. So I can type A like this. It will give me what I want. It will not say, or it will not get any error because of having an uppercase and a lowercase. An uppercase within the lookup vector. What is this? Let me do this. Sorry. In the lookup value, even if you have a small case, and in the lookup vector, you have the capital letters, what we call uppercases, it will still see each other because they are not case sensitive. So if we type D, this is what is going to happen. But if we type Z, we'll get 47%. If you type Z like this, it will assume that Z and E is actually the closest to Z, so it will give you 47%. Similarly, if you type Y, you still get 47%. If you type C, you'll certainly get 35%. It does not look at the exact match. Anything that is outside your lookup vector, it will find something that is closest to it, and that is what you're going to get. Maybe that is a disadvantage, because with VLOOKUP, it has the ability, once you actually set it on 0 or false, it has the ability to give you the exact match. If you do not have the exact match, it is going to give you an NA error, not applicable. Okay, Makwanisa, Crispin, is it okay?
Okay, I missed the first part when first part we're trying to explain how to use it.
Okay,
I think I missed the introduction. I was having challenges with my internet.
Okay, let me just redo it. All I'm saying, if you pick this lookup, Control A, press OK, it has 3 syntax arguments. Usually, for me, as long as the lookup vector and the result vector, this is the lookup vector here, and the result vector, they are close to each other, I don't go to the result vector down. So I'll pick the lookup vector where I say the lookup vector is cell-based. It doesn't pick a range. So in this case, we want to pick A3. We want that tax code. Okay. So we want to know what is the rate for this tax code. So I'll come to the lookup vector. Usually what I do, I would pick this because I know that this is the lookup vector. But if I leave it like this, if I don't go to result vector, the answer here is going to give me A. You can see it's A, the preview. So usually what I do, I always avoid going to the result vector. So I'll just highlight up to the last column within this particular range. That column, automatically, it actually represents the result vector. Yes. So I'll leave it like this. But since we are learning, we are saying we first start with the lookup vector, we pick it like that. We go to the result vector as well, we pick it like that. Then we can press OK. So tax code A, the rate is 5%. If we type tax code B, the rate will be 15%. If you type tax code E, the rate will be 47%. But here's the weakness with this function, for this function. The weakness of this function is that if you go beyond the lookup vector, it will give you an approximate. It doesn't know, how did I say? It doesn't know how to say no. It cannot say no. So it will still give you a number. So you might be deceived if you don't understand the anatomy of this particular function, so to say. So if I type Y, because Y is closer, it's going to check within the lookup vector which one is closer to Y, to E. So if I type Y, E is closer, so it's going to give me 47. If I type A, this is what is going to happen. And the way it is, you have to actually, the problem that because it doesn't give you an error, if you don't know how to use it, it's going to be very suicidal. It is not like VLOOKUP. If you type 0 or false, you're actually saying you want an exact match, and you still get an exact match. If that is not within that lookup array, then it's going to give you an NA telling you this is not applicable. Unless you set the VLOOKUP on 1 or you leave it blank on the last function argument. Oops.
Oh.
So that is a problem.
I get it. I see.
So you can see. Then if I type,
yeah.
Then if I type a dot here, unless I type a dot, then it gives me an NA. But anything that is closer like these letters there, it is still going to give a 47 like that.
Oh. I see.
So it is a bit misleading, but you need to know how to use it. It is a very powerful function.
Yeah, it is against.
So where does it apply if it gives that kind of the numbers are not accurate? Like where do you?
Let me give you an example. This is how it's going to apply. Let's say, for example, we have. I'll type province here. I'll just type, say we have Lusaka province. Also just do that so that you understand how it works. It is a very nice function. You have Lusaka province, you have southern, you have, say, northern, you have western, then we have I don't want to have so many of them. We have Lusaka, southern, northern, western, and eastern provinces. So these are provinces. So we are told, according to the codes, anything that is between 100 and 199 is Lusakas. So, and you have to arrange them nice like this. So we are saying you're coming up with these codes for the town, for the provinces. Okay. So imagine here you have a town, you have a code for this town. These are headers. So you have Choma, you have Lusaka itself, you have Kafue, you have Mongo, you have Petauke, you have Lundazi, this example, just assume Vero, that these are your customers dotted around the country from specific towns, and you're extracting this from your database. You have Kalomo, you have Kasama, you have Porokoso, you have Vuvi, you have Kaoma, Senanga, is Chongwe is not in Lusaka? Chongwe is in Lusaka, eh?
Yeah, Chongwe is in Lusaka.
Okay. So you have Chongwe, for example, like this. Okay. Then you have maybe Monze, like that. This is from the database. And as you're extracting this from your database, it's showing that because Southern, it is within 200 and 299, but the code for this specific town is 210. Lusaka is 100 to 199, but the Lusaka code is 125. Kafiwe is 140. Mongo 400 for 499, so Western. So Mongo is 415. Eastern Province is maybe 535. Lundazi is 511. Kalomo, which is under Southern Province, is 221. Kasama, which is under Northern, it is 304. Polokoso is 355. Vuvi in Eastern Province is 562. These are codes, town codes. Kaoma, which is in Western Province, is 477. Senanga is 419. Chongwe, which is in Lusaka, is 160. Monze is 213, like this. Just type them like that. Type the town, type the code. So just assume that you're extracting this information straight from your database. It could be Oracle, Science System, depending on whatever database you're using. These are your customers. These are your bank customers. And maybe here you have the loans that they got from this specific whatever. These are customers. They're quite a number, maybe even under Choma, they're 100 or whatever. So the loans here will say this one got 50,000. This one got 75,000. And just do a rank between, then you can copy those. Don't follow this formula. You can just pick the numbers at the end there. But let me just, okay. I know I'll disturb you if I do this. 30,000 to 70,000 on, just for quick whatever. You can put whatever numbers you want to put there. I just wanted to use a random number. So you have, these are the loans. So you want to do an analysis, a serious analysis, and this is on customer specific. So you have this spreadsheet, which the data that you extracted from your system is giving you maybe over 20,000 rows of data with the town codes and the loans. Just imagine that it is 20,000 rows of data. You want to do a quick analysis so that you get to know per province how much loans, how much loan portfolio per province. Vero, are you getting me?
Yes.
Maika, my numbers, have you put the numbers under the loan column?
I'm putting them right now.
Yes.
Okay, I'm giving you, I'll give you a bit of something. So, but just imagine that this data you're getting, it is customer data. So you have names here, which obviously we're not going to put. You have names here. Name 1, 2, 3, customer 1, 2, 3, whatever. These are your customers. Maybe I should call it customers so that you visualize nicely. Not customers, customer, that's the right term. Customer 1, customer 2, customer 3, up to customer 20,000, spread across the country. And maybe these are transactions, or this is basically a loan book. But the analysis you want to do, you want to know per province, how much loans you have actually rendered per province. That also gives you an understanding. There's an analysis you want to do. First, you want to understand based on the provinces, based on the loans that they have gotten, which province has a higher risk appetite to borrowing, so that you focus on that as a bank, or which province doesn't have the appetite to borrow, so that you can take your marketing strategy in that particular area. You have to first understand what is actually causing this problem. Is it economic activities in that particular province? Is it because you do not have the presence, the proper presence as a bank? What is really happening? Is it because your managers domiciled in those particular provinces, they have problems? You can use this analysis. Maybe also you want to check on the NPLs, how do you call them? Non-performing loans.
Yeah, NPLs.
So that you get to understand what is actually causing these NPLs in specific provinces. So that as you see the economic activities going down in certain provinces, you can actually measure how much you expect to lose because the economic activities are actually going down. Or maybe you're actually worried with what is happening in the mining sector. Maybe you think that there will be an issue of people losing jobs and all these other things. So you want to know in advance so that you start coming up with strategies on how you can ensure yourself from losing so much because people will start defaulting these loans. The other thing, obviously, you just want to have information to know which province is actually giving you the most from your loan portfolios. So then you need to come up with a column here, which basically shows the province. But then this column, it is not there in your database. The native data set you have actually gotten from your system, exported it in Excel or in any form of spreadsheet, you do not have the province. But you have what we call a mapping matrix. You have it. So you have this mapping matrix, and this is what you're actually going to use. So this is how you're going to do it. This is method 1 that I'm going to show you. Just do like this, equals lookup. It is a very powerful function, guys. Let me know once you open the function argument box. Frida. Have you opened the function argument box?
Yes.
So the lookup value, Crispin, Veronica, is this. You go into where you have this code, the 210 code, the trauma code.
Okay. Okay.
Like I told you, it is actually a cell-based. It is cell-based, so it's just one cell. You are not picking a range. Then the lookup vector, you get in there. So the lookup vector, you know that you pick this first one up to there. I'll show you method 2, the way I do it. Then the result vector, you go to the result vector. The result vector, you pick the provinces here, that range. But please lock, I forgot. Lock, even the first one on the lookup vector, please lock. Vero, I'm sure you know how to lock. You haven't forgotten, isn't it?
I can remember.
Please try to anchor. There should be 4 dollar signs. And Crispin, you really need this function because I know you'll be doing this analysis. It is very important in the industry you have gone into now.
Yeah.
Because in microfinancing, obviously, you have presence in all the provinces, isn't it?
Yes.
So just on the lookup vector, is it that we are starting from which one?
So the lookup
The
vector.
whole,
Yeah, you're picking from 100 to 500, just that column.
or just the column? Okay.
Yes. That is the one you want it to look up with the result vector, the other side on the provinces. But I'll show you method 2, the way I do it easily.
Okay. So I've done that one. Then the one at the bottom result vector, you're picking the provinces.
The provinces, yeah, because that is where your results are. That is the column which will give you the results which you want.
Okay.
So the lookup value is a code, which is in this case it will be M11, isn't it?
Yes, where there's 210.
And then
because you want
there's 210, yes.
Yeah, you know that Choma, the code there is 210, but you want this code to use. You want to use that code to fish out the province.
Okay, all right. I see. Okay, I see. Okay, so then the lookup vector, of course, it will be that range from 100 to 500, isn't it?
Yes.
Okay, and then the result, of course, it will be from Lusaka to Western Province.
Yes, to Eastern Province, not Western. Eastern Province.
To Eastern Province,
yes.
So Eastern Province, yes.
Sure.
I see. Okay.
So once you are done, if you have locked, Vero, have you locked?
Yes, I have.
Then you can press OK and take it down like this.
How come mine hasn't come? It's saying not applicable.
How?
Let me check again.
Just check on your formula. Let me just open it. Crispin, have you managed?
It's also not. It's giving me an error.
Vero, are you able to share your screen?
I'm using 2 devices, so I'm using. Yeah, I'm not able to share unless I log on to this one on Zoom. I'm still trying to access it.
Crispin, are you able to share your screen?
Okay, let me see if I can share.
Okay, let me first just give you the rights to do that.
Okay.
Okay. You can share your screen now.
Okay. Can you see? Are you able to see?
Not as yet, but I'm sure it will.
Okay.
Right. Are you sharing? Have you shared?
Yes, I'm sharing now. I think you will see it.
Okay, it's about to come.
Are you able to see it?
Yes, yes.
In Zoom on the laptop. But maybe you can also see it, but it's not giving me the right, it's still giving me an applicable, not applicable.
Just check on those numbers. Maybe the number you have there.
Maybe the problem is on locking, because what I did initially, I was locking manually, and that's why it didn't give me those values. Maybe you can just on locking, just try to press F4.
Did you lock? Did you put the dollar signs?
Yes, I locked it. Okay, let me look at the formulas again. But I locked it. I remember I locked it.
Send your screenshot to my WhatsApp.
Okay, let me send it.
It's a powerful tool.
Yeah, it is. It is a very powerful tool. You see then what we're going to do later on, we start doing the analysis and the like. It is a very powerful tool. But highly underutilized.
Especially in the financial institutions, it definitely has to make sense. It can be very helpful.
Definitely would be very helpful. Very, very.
It can be helpful. I mean, like.
Vero, Namanjo, you haven't yet sent.
Gurus, eh?
Yeah?
I've sent it. No, I've sent.
Okay, let me
I've
just
sent a screenshot.
Okay. I'm checking. From Kambira Papi one. Change Vero, not from K. Oh, sorry.
Bring the mic again.
Hello, Vero. Sorry, my internet is bad.
Yes.
Change, not from K. Pick L. You're picking the code, not the town. You are picking the code. You picked the town instead of the code 210.
Oh.
Where you have K9, change it to
the code.
Change it to L9. Hello? My internet is very bad.
K9. Where is K9 here?
Check in that formula.
Oh, where there's K9, I should pick right.
You should pick L.
Okay. I've seen it now. Okay, it has come now.
Yeah, so take it down. Take it down.
It has come. Oh, I was supposed to pick the code, not the town, eh?
Yes, the code should actually rhyme, or,
it's okay
or should, yeah, it should rhyme with the first range here where you have your lookup vector. It should be the same principle you use when you're actually using your VLOOKUP.
No, it's correct now.
So.
Okay. Oh.
So imagine that was 20,000 rows.
I understand now. So it. I was saying that the fact that we're saying it picks the one which is closer to the number. So I've seen if it's Lusaka, anything below the 299, it will pick Lusaka.
Yes. So method 2, the way we would do it, instead of going into using 3 syntax arguments, remember that you have used the lookup, you have gone to, when you do like this, the way I'll do it, I'll only use the lookup vector and the lookup, you're making noise, Frida, stop. I'll use the lookup value and the lookup vector only. I would leave the result vector, because the result vector, if I leave it, it will assume that the result vector is the last column in your lookup vector. So I would pick this 210. Let's just do it together. Then I would go to the lookup vector. Let's do it together. And then I would pick this whole range like this and lock it.
Oh, the whole range. Okay.
So it is intelligent enough to know that the result vector is the last column of the lookup vector. Those keys are for the office. Just put them nicely, otherwise I'll chase you from here. So you lock, then you press OK. And you just take it down like that. Still the same thing.
Okay.
Oh, yeah.
So I'll get this because I want to do an analysis on the loan portfolio by province. So that I give this data to the board of directors or whoever is in charge of strategy, since I'm in marketing and all that.
So sorry, but for me, it's giving me just Southern Province, everything on a drag.
No, meaning you locked your 210 here. It shouldn't do that.
Oh yes, I did. Okay, see. Yeah, I did. Okay.
So here I'll continue with my analysis. I'll then put the loans.
Okay.
Then I'll actually show the percentage share. Of these loans. Then I'll come here now and use the sum if. So let's go to the sum if briefly. So under the loans here, I would say equals sum if. Open the sum if. So the sum if has 3 syntax arguments, a range, a single criteria, and some range. So open, do your control A like that, because I want to do my analysis nicely. I'll come there. Have you opened the function argument?
Yes.
Let me know if you have opened that.
Okay, yes, I have.
So from here, you go to the range. A range is an array. So which range are we picking? We are actually picking a range for the provinces, this range here. You lock it like this. You lock it. Just lock.
Okay.
Then you go to the criteria. Which criteria? Criteria always is a single cell. So we'll pick here on Lusaka. So you go to Lusaka. Under that table which you want to use for your analysis, you pick the province, whichever province it is. Let me know if you're done.
Done.
Then now, because you're trying to pick the loan portfolios, so you go to some range on your data sheet where you have all the customers with the loans that they got, because you want to analyze them per province. You pick the whole range. Please do not forget to lock for anchor.
Okay.
Then press OK. Take it down like that. Obviously, down here, you want to get the total.
Okay.
Vero. Yeah.
Sure, ati mavutika.
Imakosako. Ati musebenza na maovertime bakupasani.
Then
your story is not yet over. So then you come this side. Take a percentage. We put the average because we want to see whether you have managed to beat the average. So you do like this, you say equals average. You pick from here up to there. You cannot leave average from your analysis. So you have the average, so it shows your average. Let me just remove these points. You see what we're going to do.
How did you find the average? Sorry, I missed it.
There's a formula called the average. Let's do it together.
Average.
I know now you are. Equals average, not average A, pick average.
Average, I remember, but what did you use to? Oh, so you pick the
the orange.
And then you drag it for that.
Yeah, you pick the orange, then you drag it down there.
Okay.
So meaning here, what you're trying to do, for those towns that have loans above average, meaning that they are okay, because you obviously work in the loan portfolio or whatever. But if you're in marketing, those towns that haven't gone above average, meaning that those towns, maybe you need to do a lot of sensitization. What is really happening in those towns? But then you can also go on. Once you do this, you can still go on and put the population here. Data which you can easily get from Central Statistics Office on the websites and whatever, to show, instead of just comparing the loans against the average, to also show as a proportionate of your population per town.
Oh, yeah.
And that population, you know what you do with that population. That population, say in Lusaka, you have 3 million people. This is data analysis, guys. You have 3 million people. Let me do this. You have 3 million people. The first thing that you're going to do, according to Central Statistics Office, is that if a family, the average number per household is 5.1. So we'll do like this. So we know for sure that we have how many households? We have divided by 5.1. So in Lusaka, you have 588 families, 588,000 families. But from here, you actually assume, because obviously again on Central Statistics Office, it shows that 68%, and this data is there. You are using this as assumption, 68%. They are unemployed or employed, or those that are employed is about, I think, maybe 21 or what percent. So you use this, then you pick 21%. You have 21% here, which shows, for example, those that are employed, because you are targeting, in a way, you are targeting those that are employed, not maybe businessmen or whatever. You're saying first you're targeting the salaried one. So you pick this and multiply by 21% based on the number that you've been given by Central Statistics Office, numbers which you could, basically it's by Central Statistics Office. So it will show you that the people that you are targeting in Lusaka are about 123,000. So that is what you're actually going to show here in terms of the workforce. So for Lusaka, for Southern Province, whatever, you do the same thing. So each province, it shows how many people. If you go on Central Statistics Office, it shows the percentage, employment percentage, which if you want from this 21%, you can bring in what you would actually call more of, what do they call that? There's what they call compression rate under real estate when you're modeling real estate, which you can reduce this 21% to say out of this 21%, maybe you bring it to 17, but you come up with a reason. Wait until I finish this. So this is where now you have your expected, your total market. But again, from this total market, you know the market share per each bank. And here you know as a percentage of the market share. For your bank here at Trasmara, you know yourself, you know that in this particular industry, there's Zanaco, there's Atrasmara, there are all these Barclays and Absa or whatever. You know your market share. So you can bring in again your market share. Say your market share, in this case, we're actually saying, for Lusaka, say you have 123, the total market. Your market share as Absa, maybe it is just, for argument's sake, say 12%. So you are saying from this 123, for those that haven't yet been captured, all you want is just 12% of that, 14,000. But you have only captured from the 14,000, you have only captured 5,000, meaning that you still have this gap. So you can put how many you have captured in Lusaka. Then later on now, you can now look at the loan percentage as a percentage of the loan share, the total loan share. This is where now you get in here divided by the total amount here, which gives you that percentage. So as a percentage of loan share, you know for sure that Western Province and Lusaka, they are almost at the same, they are at the same rate. But then it shows you again that maybe in Western Province you have penetrated more. If say in Western Province, you find that Western Province, those that are working, they are actually maybe less than, maybe they are just about 24,000 for argument's sake. So you know that you are doing fine in Western Province than even in Lusaka. As much as you have the loan as a percentage of the total loan, Lusaka and Western Province are giving you the same. So under Western Province, you design strategies just to maintain these customers that you have so that they don't leave you, because you are almost reaching the concentration levels. But in Lusaka, you still have a gap. Your strategy there would be to have more people. But then even when you do all these things, you bring in now the NPLs as well. And you have a complete analysis.
Yes, this is quite interesting. So total market, of course, we have 123. So is this total market, this is for the whole Zambia or is that for Lusaka?
No, just for Lusaka. For Lusaka, you see what it is. Here, you can have a total population. The population. This is data which is readily available.
Okay.
So you have the population here. For example, there I was saying you have 3 million population here, right? But this 3 million, all you're actually doing, you have per household, which is 587. So all you're doing here, you are just saying this 3 million divided by per household, which is 5.1, which you log.
Okay.
Then times 21% the employment rate, which you also log, which gives you that.
Okay.
Then you're actually saying, with all the banks, the financial institutions, you are at 12% market share. So you are picking this total market times your market share of 12%. So it gives you the market of 14,824. But yet you are also showing the number. Here, you're actually, if you're trying to complete this, you're actually showing your customer base, those that got the loans. So it shows you that your customer base here, you're still at 5,000, meaning you still have a task based on your market share before you start eating into other banks' market shares. You still have about 10,000 customers that you should target before you even start thinking of stealing customers from Barclays, from all these other banks.
Okay. I get it. Okay. Yeah. You are gurus for sure. This is good. This is really good.
How did you find these percentages where they've grown?
Yeah.
My percentages are, I think
yeah.
On the loan, 24, 18, 16.
So these ones, what you're actually doing there, you're actually picking the loan per province, this, you have seen, divided by the total loan portfolio for the whole country as the Atlas Mara. And you lock it like this. Then you take it down. Because you need this number in your analysis. These are headline numbers where you're able to say Lusaka has 24% of the total Atlas Mara loan portfolio in the country. So this particular range is your headline, what we call headline numbers. In your presentation, and whenever you go out there, you're actually making presentation to the press. Those are the numbers that you use for the press. You don't use absolute numbers. No, you use these numbers.
Okay. I see. Okay.
Very interesting.
Very. So you
very interesting.
So from here, you can have a number of analyses. Just based on this table, you can have a number of sub-analysis. One of the sub-analysis would be, you want to know the number of customers per province based on your share price, based on the market share. You basically know that you have only done 34% of your potential. So meaning that you are remaining the biggest work that you have about 66% of those customers that haven't yet been captured by any of your competitors, which you should go in before you start thinking of stealing from your competitors.
Yeah.
Hello, is it making sense?
Yeah,
Too much.
A lot, actually.
Yeah. You spend a lot of hours now trying to prepare, even sleep in the office, try to yeah, something that you can just do within 10 minutes.
You forget. You
If you
start doing your
involve
own
gurus.
thing. Yeah. You start doing this is why you're at the academy.
Yes.
This is why.
Yeah.
Yeah, that's good.
So you have seen from just a very innocent function, how you can use that function to do all these things.
Yeah.
So the advantage of this lookup function, even if things are not arranged in order, you can still get like the way it is here. You can see these were actually arranged nicely, but this one here, it is not. It doesn't matter how it is structured and the like, you still get it. These you are actually going to do because the concept is the same, guys. You pick there.
Yes. Okay.
You pick your lookup vector, you lock.
Which is the code.
Then you pick now the lookup, the result vector. So you can do all these things. So we'll end here with this understanding that you are going to check on your company data and see how you can use the lookup function and combine it with your sum if to do the analysis that you need to do. So before we end, we always need to check out Kylie. That is what we do here at our academy. So Vero, just check out, tell us what you have learned or you haven't learned.
It's been just this what's this lookup and the sum if. I'm even looking at what I've been working on this past week. I could have used this function.
True.
So it's a very good function. I think with what I need to finish off tomorrow, I'll try and use it. Yeah, no, it's very good. Thank you so much.
Okay, thank you, Crispin.
Yeah, but honestly, even me, it has really opened up my mind. Because initially I thought it was just one of those things. Like the way you started also to say it has a bit of some weakness, but but seeing what kind of analysis I think it's a very powerful tool.
Yeah,
especially that for me on my part also where I'm going, I think I've been doing a lot of analysis. So it will definitely going to help me. Thank you so much.
Sure. Thank you so much. So see you tomorrow. I don't know what time we are meeting tomorrow. Let's meet a bit early so that I can go and relax a bit.
No problem.
Yeah. So what time?
No problem. I think I'm free in the afternoons.
Yeah. So 14 hours.
I'm free in the whole afternoon. I don't know about my sister. What?
Vero, is
yeah,
it okay?
It is.
It's okay.
15, huh? Okay.
Yeah.
Okay, thank you so much
15?
and bye-bye. Yeah.
Yeah.
Okay. Thank
Not
you so
a problem.
much.
Thank you very much. Thank you so much.
Bye.
Bye.
Okay.
Bye-bye.